Hi, seventh grade. Welcome back to another week of online science learning. All right, I'm going to get right to it because we have a bunch of stuff we have to go over today. First of all, I want to highlight what we're doing this week. So we are finishing up 7.2, fully covering 7.3 today. So your homework for tonight, after I go through the book images with you, is to go back and make sure your book is highlighted and annotated like mine so that when you take the online quiz, you have all the information that you need. I also want to point out that I've posted the Achieve article for the week. So this week is the Science Achieve. And rather than posting it later in the week, I decided just to post it on Monday. It's not due till Friday, but this week, whenever you have time during the week to get it done, you can do it. And then on Wednesday, we are going to be having a Zoom online class live. Course 2 will be from 1 to 1:30, and Course 3 will be from 1:30 to 2, and I will go over 7.4, Section 7.4 at that point. Um, all right, so let's get going on the balance of 11.2 and 11.3. So we are again moving through this kind of quickly because I just want you to have an idea of what the atmosphere is made up of, what some of the characteristics of it are. And so this is finishing up section 11.2 where we start to look at how does altitude affect air pressure and density. And basically, the general rule with altitude, and this makes sense. So and they give you the analogy here of a book. So if you have a stack of books, it says which book has more weight on it? The second book from the top or the book at the bottom? Well, the book at the bottom obviously has more weight on it because it has the weight of all the books above it. Whereas the book that is second from the top only has the weight of one book on it. And so the same thing applies when we think of air pressure. Remember last week when we talked about air pressure, we talked about how air pressure is like a column of air molecules, and the weight of those molecules pushing down on us. And so the lower you are, the closer to the surface of the earth you are, the more of that atmosphere above you is pushing on you. And the higher you are, the less. So one relationship between altitude or one relationship having to do with altitude has to do with altitude and air pressure. So the higher you go, the lower the air pressure will be, simply because you have less atmosphere above you that is pushing down on you. All right, the second relationship with altitude has to do with density. So as we go up, the density of the air is also going to decrease. So and I've drawn this in for you down at the bottom, if this is the number of molecules in this sample of air, this amount of air at this point of the mountain, higher up, the molecules are going to be further spread apart. And closer to sea level, the molecules are going to be more compact. So you're going to have more molecules in a given area lower and fewer molecules in a given area higher. All right, so again, basically when you think of altitude, you think the higher I go, the less dense the air is and the less air pressure I have. Both of those relationships are true, I should say. All right, let's move on then. That was the end of 11.2. So 11.3 then starts to look at the different levels of the atmosphere. All right, and it says, talks about a hot air balloon ride and how high you could go before you'd start to feel the changes in the atmosphere around you. But basically, there are four main layers of the atmosphere. And it says right here, these are classified according to changes in temperature. All right, so let's get to these layers. The troposphere is the first layer. And the troposphere, if you look down here at this little slice of orange, this is the troposphere. The troposphere goes from, the bottom of the page you can think of being the surface of the Earth up to about 12 kilometers above the Earth's surface. All right, and what to know about with the troposphere? Well, the troposphere is what we live in, the atmosphere that we live in, right? So it's going to be the atmosphere where weather takes place, where you have precipitation, wind. It's also going to be the level of the atmosphere where you have cloud cover, where you have clouds that form and reside. The clouds reside in the troposphere. Let's see what else your book says. As you know, the closer to Earth's surface, you're going to have a temperature that you and I exist in. And depending on the season, that temperature might vary. Or if you live near the equator, the temperature is going to remain somewhat constant throughout the year. As you continue to go up into the troposphere higher and higher, the temperature is going to decrease. And you can think about this when you think of mountain ranges out west. So in Colorado, and I think even in California, there are parts where you can be at the beach and going swimming, and then you go up the mountain, and because the temperature is decreasing as you're going up in the atmosphere, you're able to ski. So you can see this, like I said, we don't have mountains like that around here, but you can see this if you've ever been out west, the change in climate just based on the temperature change in the troposphere. So for every kilometer you go up, it's going to drop 6.5 degrees Celsius. And at the very top of the troposphere, at this 12 kilometers above Earth, it reaches a fairly constant temp of negative 60 degrees Celsius. All right? So moving on then, the next level up, so if the troposphere is orange, the stratosphere is going to be this lightest color of blue. And so the stratosphere is going to go from about 12 kilometers above Earth to about 50 kilometers above Earth. And let me zoom in here. In the lower stratosphere, okay, you're going to have the temperature be about what it was at the top of the troposphere. Negative 60 degrees Celsius. But as you move up in the stratosphere, in these upper areas, it's going to actually be warmer. And that's because in the stratosphere is where we have the ozone layer. And remember, ozone is a molecule that is comprised of oxygen, but unlike oxygen gas, which is made up of 2 oxygen atoms, ozone is made up of 3 oxygen atoms. Okay? And so that ozone is going to absorb a good amount of the solar energy from the sun, and it's going to turn that solar energy into heat. Likewise, it's going to, some of what it absorbs is going to be the harmful UV rays that, if they were to reach us on Earth, would cause something like sunburn. And so the ozone layer has an important role because it's going to protect us from some of the intense heat as well as some of the intense rays from the sun. Just a little aside, this is the layer, if you are on an airplane, this is the layer that the plane flies in. The plane will fly in the stratosphere. And as you see here, I answered these questions, so go ahead just to keep practice with reading graphs and answer those in your book as well. All right, the next level up. So if this is the troposphere and this is the stratosphere, the next level up is the mesosphere. And the mesosphere, the mesosphere runs from about 80 kilometers or 50 kilometers above. Oh yeah, I'm sorry. I was not low enough. This darker blue is the next level up. We're right here in this medium shade of blue. And so the mesosphere is going to run from 50 kilometers above Earth to 80 kilometers above Earth. And it's going to be fairly chilly. In general, the temperature in the mesosphere is about negative 90 degrees Celsius. All right, and the main role of the mesosphere, the main job it has, is it's going to protect Earth from meteoroids. And meteoroids are chunks of stone and metal that are found in space, and they come flying through space. And as they hit the mesosphere, they burn up. And so that protects them. It protects that mass from hitting Earth and causing destruction. All right. And whoops, that's not what I wanted to do. All right. And the last layer we're going to talk about is the thermosphere. So the thermosphere, and unfortunately it's on the other page, so I'm going to go back one. The thermosphere is actually divided into 2 layers. So from 80 kilometers to 400 kilometers above Earth, we have the ionosphere. And from 400 kilometers above Earth and beyond is the exosphere. All right, so those are the 2 layers of the thermosphere. And the thermosphere is going to be very hot, upwards of 1800 degrees Celsius. But as your book points out, if you had the ability to go up to the thermosphere and hang out, it wouldn't feel that hot to you. And the reason is the particles that are up in the molecules of air that are up in the thermosphere have a lot of energy, which is why they have a mark. Temperature is a measure of the average kinetic energy of the particles of a substance. And so the temperature is high up there because the particles have a lot of energy. On average, the particles have a lot of energy. But the particles are spaced so far apart that the chances of one running into you and hitting you so that you would feel that heat is very, very, very small. And so even though it is very hot up there, if you were up there, you wouldn't actually feel that heat. You wouldn't feel what 1800 degrees Celsius feels like if we think about that temperature on Earth. All right, got that. And I talked about the two layers. All right, good. And that's it. That's the end of it. So this section was really just about the layers. I want you to understand the 4 layers of the atmosphere, and make sure that you have your book highlighted and annotated for the quiz. You will be having a quiz on 7.1 and 7.2, a combined quiz, open note quiz on Thursday. So make sure your book is ready for that. And remember to please attend the Zoom session. So course 2, I have you from 1 to 1:30, and course 3, I have you from 1:30 to 2. All right, have a good Monday, guys. I'll see you later. Bye.